The second method is the so-called the Gauss method. I can't say if it's easier or shorter than the previous one, but you should know it in case you are asked to calculate the inverse of our matrix using this method. Look.
Binnacle project.
The process involves positioning matrix A here, and to the right, typically separated by a dashed line, we place the identity matrix, in this case of order 3, of course. The goal is to use elementary operations to make the identity matrix appear on the left side. The structure that remains on the right side will be the inverse of our matrix, which is what we are looking for. Naturally, it should give us the same result as the inverse matrix using method number 1. Let's get to it. It's important that you follow the steps I'll show you in the next few minutes to avoid getting lost in this process. Look. Well, first of all, let's copy row 1, because it's the row that we are going to use as a support, as a pivot. 1, 0, negative 1, 1, 0, 0. And what are we going to do? We are going to use this position to kill these numbers. In the next step, we are going to put 0 and 0 here, but using the proper operations. What can we do? You can multiply row 1 by any number you want. You can multiply row 2 by any number you want. And you can add or subtract them. Okay? So, why don't we think that row 2, or new row 2, equals 2 times row 1, and thus we are getting a number 2 here, and we're subtracting row 2. Look how it works. 2 times row 1. Let's put it here. 2, 0, negative 2, 2, 0, 0. Minus row 2. As I'm going to subtract, I'm copying row 2 but changing the signs. Negative 2, 1, 0, 0, negative 1, and 0, as I am subtracting both rows. And there you have it. 2 minus 2, 0. It's the 0 we were looking for. 0 plus 1, 1. This is negative 2, 2, negative 1, and 0. This is the new line 2, the new row 2. 2, negative 1, and 0. See how easy it is? We've just multiplied row 1 by 2 and subtract row 2 in order to obtain this 0 that it was the number that we were looking for, okay? And now let's use the same procedure to kill this number. We're going to use again row 1 and row 3. Why don't we multiply row 1 by 2 and let's subtract row 3, that is, the new row 3 will be 2 times row 1 minus row 3, and look how it works. 2 times row 1 again, 2, 0, negative 2, 2, 0, 0. And as I am subtracting row 3, let's copy row 3 but changing its signs. Negative 2, 0, 1, 0, 0, negative 1. And there you have it. 2 minus 2, 0. This is the 0 that we were looking for. 0, negative 1, be careful with the signs. 2, 0, and negative 1. This is the rest of our row 3. 2, 0, negative 1. First step of Gauss completed. The second step of the Gauss method involves sliding along the main diagonal and using this position to eliminate the other ones. And you'll see that thanks to the discipline we've been using, none of the zeros we've achieved will disappear. With that said, let's proceed. Whoa, thanks God that these two positions are already zeros, okay? We are lucky. Imagine that instead of a 0, we have a number 5 in this position. We could use new row 1 equals 5 times row 2 minus row 1. Okay? Repeat. Imagine that instead of a 0, we have a 5 here. We could sing new row 1 equals 5 times row 2 minus row 1, and then we could achieve a 0 in this position. The same with this other one, but thanks God that we have already 2 zeros in this position. So step number 2 completed. The third step of the Gauss method involves continuing to slide along the main diagonal and use this position to eliminate these other ones. Okay? We are proceeding as on the first step. As we are going to use this position or row 3 as a pivot, let's copy it. 0, 0, -1, 2, 0, -1. And we must eliminate this number. We can do as follows. New row 2 equals, why don't we multiply row 3 by 2, and we are getting here -2, and let's subtract row 2. -2 minus -2 is 0. Okay? Let's multiply row 3 by 2, and let's subtract row 2. Look, 2 times row 3 minus row 2. Look how it works. 2 times row 3, 0, 0, -2, 4, 0, -2. And let's subtract row 2. As we are subtracting row 2, I'm going to put it here, but changing the signs. 0, -1, 2, -2, 1, 0, and 0, -1, 0. Look how this is correct. 2, 1, and -2. This is row 2. 0, -1, 0, 2, 1, -2. And that's it. And now it's time to eliminate this number. As we are using this position as a pivot, and this is the number that we are going to eliminate, why don't we just subtract row 3 minus row 1, as -1 minus -1 is -1 plus 1, that is 0. So it must work. Row 1, new row 1 equals row 3 minus row 1. And as it is very easy, we can do it here. Let's do 0 minus 1, -1. 0 minus 0, 0. -1 minus -1 is -1 plus 1, 0. 2 minus 1, 1. 0 and -1. Okay? Look how beautiful it is, because we have achieved these two triangles of zeros that will be very easy for us to have the solution. Okay? Now it's time to make the unit matrix appear on the left side. Look, this is a -1. We can change the signs of row 1 in order to have here the number 1. Look, 1 0 0, 1 0 0, -1 0 1. Okay? And it is what we are going to do with row number 2 and row number 3, and we will have here the unit matrix. Let's change the signs of row 2. 0 1 0, -2 -1 2. Okay? And the same with row 3. 0 0 1, -2 0 1. This is the unit matrix, and this is the inverse of A. Of course, imagine that instead of having -1, we have number 3 here. What you could do is divide by 3 all the elements of row number 1. On the same way, imagine that instead of having -1 here, we have 7. You could divide by 7 all the elements of row 2. This way, we could have the unit matrix on the left side, and our inverse will be on the right side. Okay? So, objective achieved. Using elementary row operations, we've managed to get the identity matrix on the left side, and everything left on the right side is the inverse of A. Naturally, it's the same result as we got using method number 1. And that's it. And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!